So last day we tried to calculate what we call g. Oliver, g is the acceleration due to gravity, which is why we often use a lowercase g for it. You'll also learn, especially in Physics 12, that it's the Earth's gravitational field strength. The reason objects fall at 9.8 meters per second squared, negative if you make it down, is because the Earth has a gravitational field strength of 9.8 newtons on every kilogram. We looked at the notion of g acceleration in a previous lesson. I said it's not really g forces, it's g accelerations. But we were trying very hard to get an accurate value. So what we said last day was, I think you found to find the acceleration you had to use d equals vit plus a half at squared. The vi canceled. And then you had a choice. You could either write it as d equals at squared over 2 or as 0.5 at squared, depending on whether you like fractions or decimals. Joel, you either would have found that the acceleration was 2 times d divided by t squared or d divided by 0.5 t squared, because dividing by 0.5 and multiplying by 2 are the same mathematical operation. Does anybody want to share me their value that they got for g? Matteo, I'll pick you here. What did you guys get? 18.6. What was your time value?
My average time value was 0.695.
Okay, that's a little low, but we'll go with yours. Okay? So your average time value was, what was it?
0.695.
So if we run those numbers for young Matteo, he would have gone negative. Why negative 4.5? Why not positive 4.5? Okay, if you tried sticking in a positive, the universe would go a little crazy because it'd be saying, wait a minute, you're telling me you accelerated down and ended up above from where you were staying. In fact, sometimes you'll even get an error on your calculator. Not in this case, but sometimes you will. So negative 4.5 divided by bracket 0.5 times 0.695. Is that what you said your time was? Oh, wait a minute. It's t squared. Square the time, but not the 0.5. More than one thing in the bottom. That's if I use that version. This version, the other version is 2 times d divided by. So you got negative 18.6. We'll go to 3 sig figs. Even that's honestly way too much, and I'll talk about why that is in the case in a second. Negative 18.6 meters per second squared. Okay. All of you will drop your value right here. So Matteo, you and I would do this. Whatever you put goes there. Now, some of you are saying, Mr. Dewick, should I divide that by 9.8? I'm actually wanting the value of the acceleration. I didn't actually say, tell me how many g's this is. I want you to find just that value there. So you don't need to divide that by 9.8. Did you get this value exactly? I'm guessing most of you did not. So, no for most of you. Why? What was the biggest source of error? Human reaction time. Whoever was timing, can you get out your smartphone right now? Open your stopwatch app. Hold the phone in one hand. Hit start, hit stop as fast as you can. That is the minimum error in every one of your time. That's your human reaction. What did you get? All of your times are plus or minus 0.2 seconds minimum, which the fact that you're only falling for less than a second means all of your times have about a 30% error either way minimum. Okay, it's human reaction time. I don't have fancy equipment. Okay. Also, I think another source of error, having 2 people made things more difficult. Because even if you were timing when you said go, Tristan, maybe your partner was a bit slow on the drop or you were too quick on the drop. Okay. The other big challenge was short free fall time. Cole, if I could have had that fall for like 10 seconds, that 0.2 seconds of human reaction time plays a much smaller part. But the fact that the free fall time was right around a second, 0.2 is a big portion of 1 second. 0.2 is not a big portion of 10 seconds. So those are my main errors. There may have been others, but those are my main ones. All of us, what we want to do is we want to calculate the percentage error, but there's a bit of a problem here. I made a very, very small typo. In front of the 9.8, there should be a minus right there and a minus right there. Sorry. So we're going to do Mateo's. By the way, what's G really close to as a number? 9.8 is really close to what nice round number? And what did you get for your value for G? Which is close to 20. You're going to be off by your error is probably going to be close to 200% or 100%. You're going to be off. Okay? No worries. I'll give you full marks. Your method was fine. Whoever was timing was a little quick on the draw. In fact, you were the group of 3, I think, weren't you? So you can just pretend none of it was your fault because there's 2 other people to blame. There you go. Beautiful. So for all of us, what you're going to do is you're going to take your experimental value for G. So for Mateo, it was negative 19.6 minus. The actual value is negative 9.81. It's actually not that. It's negative 9.806, I think. We're typically only go with 2 sig figs, so we're typically only going to use negative 9.8. But I figured this time we'll add the 1 extra digit because we're trying to do an error calculation. And I'm going to divide by negative 9.81, except if I get a negative answer, I'm going to make it positive. That's what those absolute values mean. And then times 100 to make it a percentage. So that's how you're going to calculate your percentage error. So for Mateo and myself, negative 18.6, was it 18.6? Minus negative 9.81, close off the top, divided by negative 9.81. I got a positive value here. If I'd gotten a negative value, I would ignore the negative, and then times 100 to make it a percent. I said you're going to have nearly 100% error. Was I right in my head? Pretty close. 89.6%. Anybody get less than 10? Okay. I'd say good job, but I have to be honest, Mike, that also was a fluke as much as getting any of the other values, really. Then, number 4 says, using a value of negative 9.8 for G, find V final. Okay. What was V initial? 0. A was negative 9.8. Oh, D was negative 4.5. I'm looking for an equation that has a V final, a V initial, an A, and a D in it. There is one. I want to get the VF by itself. It's almost by itself, except there's a squared. How do I get rid of a squared? Square root? So it's going to be the square root of, I guess, 0 squared for VI, Rihanna, I don't even need to bother writing. It's going to be 2 times negative 9.8 times negative 4.5. How fast did your and this should be pretty good, Oliver, because all of you were using objects that were reasonably aerodynamic. There might have been a tiny bit of air resistance, but we'll be close. 2 times negative 9.8 times negative 4.5 square root. You get that? 9.4? Yeah? No? Why must 9.4 meters per second, why does that have to be wrong? Sierra, loud and proud, you're right. Okay, so here's a bit of a problem when we square root on our calculators. In your head, what's the square root of 9? Or, what other number times itself equals 3? Negative 3. What's the square root of 16? 4. Or, negative 4. Rihanna, your calculator, by definition, will only give you the positive value, which in math, most of the time, was all you cared about. you're going to have to start to look at your answer anytime you square root something, Oliver, and you're going to have to say, wait a minute, do I want the positive, what we call the principal root? Or in this case, do I want the negative root? And Oliver, I think you'll agree with me, which direction are we traveling when we hit the ground? Down. How are we going to show that with a... Okay? That's why every square root technically has two answers. It has to, for nature. By the way, if you were wondering what your time should have been, you could, if you were bored, solve for your theoretical time value. You should have got an average time of right around 0.96, 0.97-ish. That's how I knew yours was low. Did that answer the question on the error analysis? So as far as I'm concerned, that is due today. If you want to hand it in right now or pass it to a couple of friends and they can walk it in, or hand it in before the end of class. So you're probably going to want your formula. You are going to want your formula sheet out. And a good habit, have your calculator handy and practice along with me typing the stuff in, because I think calculator speed helps you on tests. It can give you an extra 5 or 10 minutes if you get good. And you'll also find out how your specific calculator handles the various permutations of all the different equations we've been looking at. Freefall, except first we have to do a little trivia. We looked 2 days ago at G's. We looked at Colonel John Stapp and his rocket experiments. All right. In 1977, in Northamptonshire, England, David Purley's race car crashed and his speed dropped from 174 kilometers per hour to 0 in 0.66 meters. Now, he had 29 fractures. He had 3 dislocations. His heart stopped 6 times, but he did survive. As far as I know, this is the largest G acceleration survived on record. Someone may have survived more, but we don't have video footage of it. Modern cars, someone in a car accident, Maggie, may have survived more. We don't have video footage of it. But I kind of want to know how many G's this is. When I say how many G's, what am I really asking you to find? Acceleration, time, VF, VI, or D? So let's start out by going A equals question mark. And now let's start reading. That number 1977, am I going to use that at all in my calculus? That's the year. So not every number gets used. I see 174. What's that? It's VI. Why don't I like it? Units. Okay, so I'm going to write this. VI equals 174 kilometers per hour. And then I'm going to do a conversion. It's something to do with a 3.6. Divide by 3.6. So that's going to be 174 divided by 3.6 is 48.3 repeating. I'll go 48.3 meters per second. What's that 0.66? Distance. Is that a positive or a negative? What direction is he traveling when he hits the fence or hits the wall or what? Forwards, I think positive. Okay, but I'm trying to think like physics. Vectors matter. Am I going to use that 29 or that 3 or that 6? No. Problem, Maggie. Right now I have 2 things, VI and D. Duick said you need 3 things. What? Oh, VF in any car accident is going to be 0. Good. So, which equation has an A, a VI, a D, and the VF in it? Okay. If you want to write that down, you can. Mateo, could you, staring at that equation on your green sheet, could you rewrite it in your head to get the A by itself? Do it for me, kiddo. First of all, A equals.
Oh, A equals, sorry. A equals VF to 2 minus VI to 2 over 2D.
VF squared minus VI squared all over 2D. Okay, cool. I agree with that. And again, this is what you want to reach this week. You want to be comfortable being able to rewrite the equations. On the quiz, I notice a few of you are still sticking in numbers and then just solving it like Math 8 rather than rewriting the equations. It's going to come back to bite you. Please trust me. 0 squared minus 48.3 squared all over 2 times 0.66. Mateo, this is a fraction. Brackets around the top. 0 squared minus... Folks, I noticed that I have 48.3 as my answer, so I'm going to use my answer button instead of going 48.3. I'll use 48.3 repeating. Squared divided by 2 times 0.66. And you get a pretty spectacular answer. First of all, when this race car driver hit the wall, did he speed up or slow down? So am I expecting a positive acceleration or a negative acceleration? I get a negative, so that doesn't freak me out. Okay, that's negative 1,769.8 meters per second squared. That's in meters per second squared. How would I convert that to G's? Divide by? Just divide by 9.8. The negative, we already got the direction in here. So 1G has a value of 9.8. The negative just gives you a direction. We already got that here. So now, take this, divide by 9.8, and he pulled off negative, you know what? I'm going to give him the rounding off. Negative 101. Not negative 181. He's earned it. G's. The negative, he's slowing down. The magnitude, how many G's, Cole? Mathematically, that's as though, because all of you have 1 G normally, that's like he had 180 extra people dogpile on him. You can imagine a stack of 180 people. That's what he experienced. He felt 180 times his own body weight at that moment in time. I may be out of date. I seem to recall last year having something come across my feed that this record had been broken in a Formula One race car. I got to do a Google search, but last I heard, this was it. That's just to kind of review what we've done, Joel, and for a little bit of hashtag nerd trivia. Freefall. This is the theme of today's lesson. When an object is falling through the air, we say it is in freefall. Can you be on your way up and in free fall? Yes. If I throw something up into the air while it's on the way up, it's in free fall. While it's on the way down, it's still in free fall. On the way up, it's slowing down, so it's accelerating downwards, gravity. On the way down, it's speeding up, so it's accelerating downwards, gravity. Same thing. In free fall, acceleration is always negative 9.8 meters per second squared if we're near the Earth. Next year in Physics 12, there is actually a way to calculate the universal gravitational field strength. What's free fall on the moon? It's about 1.6. How'd they figure that out? We knew before we landed there. There's a way to calculate it. We knew before we landed on Mars what G on Mars was going to be. We had to. Otherwise, our space probes couldn't have landed there because we wouldn't have known how strong to build the rocket engines. Of course, that negative 9.8 changes in other places like the moon. It's about negative 1.6. Or in outer space, where if you go far enough away, goose egg, 0. I love free fall. I'm fascinated by it. I've experienced it myself. Put your pencils down. Look up. A couple of key ideas if we're looking at free fall. First of all, Brian, I will never tell you the acceleration. What's the acceleration in free fall? Negative 9.8 meters per second squared. The question will not tell you that, Christy. It'll expect you to know that, which means you always have one extra piece of information that isn't mentioned in the question. What can we find? What kind of questions can we handle? What can we calculate? What can we measure? What can we figure out? So, a cannonball is dropped from a cliff. Everybody right now underline the word dropped. If I ever use the word dropped, we can assume that VI is equal to what? When you drop something, what's your initial velocity? I'm not going to mention that one again either. I'll use the word dropped. VI is 0. It hits the ground 10.6 seconds later. Okay. David, what's part A want us to find? When I talk about how high something is, what variable is that? Because we don't have an h in our equations. What are we really talking about here in terms of our variables? Velocity? What? I'm going to be fussy. It's going to be a displacement, but yes. So, D equals question mark? David, my friend, what else do we know? So what is that 10.6? Time? T equals 10.6. What else do we know because we're in free fall? A equals? Gotta be fussy. Not 9.8. Not 9.8. Yes. What else do we know because dropped? Mr. Dewick, what if we don't drop something? Oh, if you throw something down or throw something up, then VI won't be 0, and I'll make sure I'm very clear about that in the question. But what do we know because of dropped? VI is? So I'm looking for an equation that has a VI, an A, a T, and a D. There is one. Which one, David, my friend? Yep. What do we want to get by itself? What do we want to get by itself? What do we want to get by itself? Find the thing that we wrote. Okay, try that again. You know what? Scene 1, Act 1, Take 2, and action. David, oh clever young man. What do we want to get by itself? Oh, you are ever so clever. I'm glad you spotted that right. Oh, the D is already by itself. That's convenient. David, why can I do this in this specific situation? VI is 0. What's 0 times anything?
0.
So 0 times T is 0, and going 0 plus is irrelevant. Okay. 0.5, negative 9.8, 10.6 squared. What do you get? Did you get a negative answer? Yeah? Why negative? Here's what the physics is saying. It's saying based on this, you ended up below from where you started. Oh, are we dropping something off of a cliff? Is that negative all that surprising? Actually, it's comforting. It means I probably did the physics right. I'd be more nervous if I got a positive answer. You get negative 550.564? I'll go negative 551. Now that's the displacement. When we talk about the height of a cliff, do we ever say that that cliff is negative 551 meters high? So, height is a scalar. I won't take marks off if you stop right there, Maggie. I'm fine with that. But for what it's worth, in English, we would say the height was positive 550 meters, not negative 551. So positive 551 meters, not negative. But if you just stop Christie at the negative, I'm good with that. It's a displacement. What else can we find? Misha, what does B want me to find?
The velocity.
Which velocity? And let me assure you, not 0. After you hit the ground, it's 0. But why would I even bother asking that? That's a boring, redundant question. Why would I ever say, tell me the final velocity after you hit the ground? All right. Is this the same situation as before, or has anything changed? Same time? Yeah? Same dropped? Yeah? Okay, I'm not going to relist. And have I turned the page?
No.
I'm not going to relist my defect. I've got it all in part A. Misha, I'm looking at our equation. It's got to have a VF in it, and it'd be nice if it had a T, an A, and a VI. If I have to use D, I can, but I'll avoid it if I can, because I don't want to use an answer to find an answer if I can avoid that. There is an equation that has a T, an A, a VI, and a VF in it. Oh, he's getting out his green sheet.
VF equals VI plus AT.
Okay, I need to get the VF by... Oh, it already is by itself! By the way, here, are we expecting a positive answer or a negative answer when we hit the ground? What direction are we traveling when we hit the ground? Down. I better get a negative, otherwise I've messed up. So it's going to be 0 plus. I probably could have just crossed out the VI. Negative 9.8 times positive 10.6. I don't need to type the 0 plus. It's just going to be negative 9.8 times 10.6. I get negative 103.88. I'll call it negative 104 meters per second. Is that fast, Mr. Duke? Well, that's traveling one football field in a second. If you're American, it's around 200 miles an hour, just shy of that. You could convert it to kilometers per hour, times it by 3.6, so it's about 300 and some kilometers per hour, 360 kilometers per hour. That's pretty fast. C. What's the velocity of the cannonball after 3.6 seconds? Okay. Brian, what's this question you want me to find? Which one? How do you know it has to be final? What's V initial? Because got to be V final then. Yes? This V final isn't after 10.6 seconds, it's after 3.6 seconds, but it's still the end velocity of when we're hitting our stopwatch. That's really what final means. So what was VI, Brian? And time in this case is 3.6. What's A? How will I find V final? In fact, it's the same question Misha and I just did, just different time value. VF equals VI plus AT. It's going to be 0 plus negative 9.8 times 3.6. Negative 9.8 times 3.6. Negative 35.3. Does the negative make sense? Yeah. What else can we figure out? What else do we know? What else can we calculate? Oh, I could say, hey, how far has the ball fallen after 3.6 seconds? Huh. Oliver, what's this question asking me to find when it says how far? I like. Oliver, is this the same time value as part C, 3.6 seconds? So same VI, same A. Okay, I'm not going to relist everything. How could I figure out how far? Does this equation here contain a D in it at all? I'm going to say that's a bad one to use then, because that won't tell us how far. We need something that has to have a D in it. D equals VI plus VF over 2. That'll work. The only reason I might not be wild about that one is I'm using V final to find D. If I got part C wrong, I'm getting part D wrong. But you called it. It'll work. What would be a better one to use, by the way, folks? Sierra. I might go with VIT plus a half AT squared because that uses data that's all given to me. Do you want to use that one or do you want to use yours? I can go either.
Yeah, sure.
Okay, so works, but not the cleanest. I'm going to use D equals VIT plus a half AT squared. Hey folks, why can I cross out the VIT this time? VI is 0. That won't always be the case. So it's going to be 0.5, negative 9.8, 3.6 squared. What do we get for how far it's fallen? .5 times negative 9.8 times 3.6 squared. You get negative 63.5. What's the negative telling me here? Is the ball above us or below us? Below. Okay. That's kind of what I can do if I just drop something. What if we don't drop something, Jacqueline? What if we launch something? Example 3 says this. A ball is thrown straight up with a velocity of 29 meters per second. Okay, cool. How long does it take for the ball to reach its maximum height? What's this question asking us to find? How long? Time. How long can sometimes mean distance. How long is the racetrack? But I think here, time. So let's do our DFIC approach. Let's go t equals question mark. What else do we know? What's that 29? What's that 29?
VI.
It's a VI? Positive 29 or negative 29? When would it be negative if instead of saying a ball is thrown straight up, thrown straight down? We can handle that. Okay? There must be something else I know. Oh, we're in free fall. Even on the way up, what's our acceleration?
9.8.
Not 9.8. I got to be fussy. Negative 9.8. Problem. I only know 2 things. I need 3 to find the 4th. There must be something else that I can reason my way to. What else do I know? So we're talking about this. Let's give you a visualization. We're throwing the ball straight up, and we'd like to figure out at the top how much time that takes to get there. At the top. And what else do I know? What's VF at the top for a split second? For a split second, this is where there's a V final of 0. At the top, the ball comes to rest for a teeny tiny split second before it starts coming back down. So I know V final. Okay. I'm looking for an equation that has a T, a VI, a VF, and an A. There is one. Which one? Cole, which one? He's thinking. Good. Third row down, those 4. Which equation, folks, has a T of... Sorry?
VF equals VI plus AT.
That's correct. VF equals VI plus AT. Could you rewrite it for me? Get the T by itself? Or not?
Okay.
Yeah, you.
VF minus VI divided by A.
Oh, I wrote T equals because that's where I'm used to seeing it. But yeah. So it's going to be 0 minus 29. Uh-oh. Top's going to be negative. Am I going to get a negative time? That's not allowed. Oh, wait a minute. Divided by negative 9. But the bottom's negative too. Dylan, what's a negative divided by a negative? Oh, it works. Are you positive? I paused. Nothing. Okay. It'll be a little bigger than 3, I think. 0 minus 29, close off the top, divided by negative 9.8. And I get a little smaller than 3, not a little bigger than 3. 2.96? By the way, technically I should go to 2 sig figs and call it 3.0. I'll go 2.96. Units for time. Seconds. So as far as I'm concerned, I can ask you how long. I can ask you how far. Turn the page, please. Yeah. We would have to take into account. It's a great question. So Sierra said, Mr. Duick, what if you even if I threw it, I'm kind of lowering down. So we're imagining that we're somehow launching right from ground level. You're going to see in a couple of questions from now, which one here? In example 5, I have it leaves the thrower's hand 1.6 meters above the ground, and I'll be fussy, and we're going to ignore that. Most of the time, you can assume somehow we're laying on our stomach on the ground and somehow throwing it straight up without a wind up. We would have, the answer is we'd have to take it into account somehow. Okay? Typically, we're going to end up ignoring it. B. Hannah, what's B want me to find? Which variable was the height? Because we don't have an H in any of our equations. D. Okay. Did you all just turn the page? Yes? Then let's relist our data. What was V final at the top for a split second? 0. And V initial was 29. What else do I know? A equals negative 9.8. Hannah, I'm looking for an equation that has a D, a VF, a VI, and an A in it. Can you get the D by itself for me, kiddo? Yeah, it's the squared one. I'll give you a hint. D equals. Yes. Yep. So it's going to be 0 squared minus 29 squared all over 2 times negative 9.8. By the way, Hannah, this is going to be so obvious that it's tricky. At the top, are we above us or below us? Am I expecting a positive D or a negative D here? I think so. Now the top is negative. Wait a minute, the bottom's also negative. What's a negative divided by negative? Are you positive? So let's see, I get 0 squared minus 29 squared divided by 2 times negative 9.8. Okay. You launch it, I can tell you how high it's going to go. This one's going to go 42.9 meters high. Is that right? Anybody else? C. What's the impact velocity of the ball just before it hits the ground? By the way, whenever I talk about impact velocity, really what I mean is what's its velocity when hitting the ground? What's this question asked me to find? VF. Isn't it 0? Misha, is it 0 after we hit the ground? Well, sorry, the impact velocity when we hit the ground, is that 0?
No, not yet.
What else do I know? Oh, A. Negative 9.8. What else do I know? Oh, what was VI? VI was 0? positive 29. That's two things. I need a third thing. Could I use the distance? What's my distance? The answer is yes, but I got to be clever. So you ready? How high are we when we started? On the ground. When we start? How high are we when we finished? On the ground. Yes? Yeah. So what's my displacement? By the way, it's a displacement. What's my vertical displacement?
0.
Looking for an equation that has a VF, an A, a VI, and a D in it. There is one. Which one?
VF squared equals VI squared plus MAD.
Cool. Okay with that, folks? Hey, why can I do that? Why can't I cross out the 2AD? Oh, D is 0, so what's 0 times 2A? So I get this. VF squared equals VI squared. How do you get rid of squared? So you tell me, what was VI? 29? What's VF? Now we have to be careful, unfortunately. It's not 29. Matteo. Because that, when you take the square root, did they want the positive answer or the negative answer? We did square root both sides, but did they want the positive answer or the negative answer? Which way are we traveling when we hit the ground? I think we definitely want the negative answer. So we can say this. Now, we're not going to walk through that proof again. This is one of those things that we're just going to remember. If you start in it at the same height, your initial and your final velocity are the same, but one's negative. Or, the way it's often phrased in English, what goes up must come. Oh, please, fill in the gap. What goes up must come. If you kind of remember that little saying, what we're really saying is, if you leave the ground at 80, you hit the ground at negative 80. If you leave the ground at 75 meters per second, you're going to hit the ground at negative 75 meters per second. What goes up must come down. Now, the reason that's the case is because your displacement is 0, since you started and ended on the same height. And there's our algebraic proof, Oliver. You do get VF equals VI. You don't get the negative VF, but that's because your calculator assumes you want the square root. In this case, I actually would want the negative square root. You can put a little negative in front of there if you want to. Question, or is that okay? Let's answer E, then we'll go do D. What's the displacement of the ball once it hits the ground? The distance it's traveled would be twice the height, but its vertical displacement, 0. D. What's D want me to find? Time. All right, what else do I know? Do I know A? What? Negative 9.8. Did they tell me VI? What's VI? 29? What else do I know? Can use D equals 0. Leave a space. write that over here in the margin. I'll show you why in a second. What else do I know? Sierra, you might have been right. What's VF? Put your pencils down, just look up for a second. Oliver, if we use D, the equation that we end up using is this one. Oh, no squared yet, Mr. Duke. Plus 0.5 AT squared. When you plug in D equals 0, you get 29T minus 4.9 T squared. I did half of negative 9.8 in my head because I can. And then you'd be trying to get the T by itself. Why is it so tough to get the T by itself in that equation? And a T. You will learn a trick to do it this year, but it's a pain. So I agree with what you suggested. This is absolutely right. But I think you'll be finding it easier to simply remember that what goes up must come, I know V final, negative. So, folks, what's an equation that has an A, a VI, a VF, and a T in it? There is one. Can you get the VF equals VI plus AT? Can you get the T by itself for me, Rihanna?
Yeah. T equals VF minus VF.
Good. So it's going to be negative 29 minus 29 all over negative 9.8. Five 5.918367. That there? I'll go 5.92. Thumbs up, thumbs down, yes, no? Am I wrong? Negative 29 minus 29. I'm right, am I not? Oh, had me worried for a second there. 5.92 seconds. Put your pencils down, look up.